In this new video, you will see how to write a simple Prolog program to find paths in a graph. So, as you may have understood from the previous videos, Prolog is particularly good at expressing relations. Several real-world scenarios can be represented as graphs, such as social network and road connections. A graph is composed by a set of edges. We indicate these edges with edge2facts, where edge AB denotes a directed edge between A, the source, and B, the destination. We consider directed graph, meaning that the edges have orientations. We now need to state what is a path. A possible definition is the following. So a path is a set of edges that, starting from a given source node, allow us to reach a given destination node. If source and destination are not directly connected, we must pass through intermediate nodes. The conversion of these two statements from natural language to Prolog is straightforward. So, if source and destination are connected by an edge, there is a path between them, by definition. Otherwise, if source and destination are not connected, or directly connected, so in the general case, we select an intermediate node connected to the current source and continue the search from these new nodes toward the destination. This can be expressed with a Prolog program as. So the first rule, path x, y in the head is true if edge x, y is true. So there is a path from x to y if x and y are connected by an edge. Then we have a second rule, path x, y, if edge x, z is true and path z, y is true. So there is a path from x to y if there is an intermediate node z from where the destination y can be reached. The predicate, recall that a predicate is a collection of clauses with the same functor, path2, is an example of recursive predicate since, in the body, there is a call to itself. Here, you can see, in the body of the second rule, path x, y, we have a call to path z, y, so a call to the same predicate. So let's add some edge2facts and write this program. Suppose we want to represent the following network with directed edges. So we have A connected to B, B to C, C to E, B to D, and D to E. To do this, we add the following facts to the previous program. For convenience, we add them before the path2 predicate. So we add edge AB, that represents this first edge. Then we add edge BC, that represents this second edge, and so on. Edge BD, edge C, edge DE. And we ask some queries. So path AB, true, we get the first true solution. Source and destination are connected by an edge, the first rule matches, and path AB is true. So if we go back to the program, path AB, x is substituted with A, y with B, so the goal edge AB is right, edge AB is true, since it is the first fact in our program, and so the first rule succeeds, and we get the first true solution. So source and destination are connected by an edge, the first rule matches, and path AB is true. However, there are choice points open, so there can be other solution. Let's press semicolon and we get false, since there are no more possible paths between A and B. Before returning false, the Prolog interpreter explores all the possible existing connections. If source and destination are connected by more than one path, for example, the nodes A and E, we obtain more solutions. For example, if we ask if there is a path between A and E, we go back to this image, so we have A, B, C, E is the first path, A, B, D, E is the second path. So we get two true solutions. Someone may have noticed that the graph used does not contain loops. Why? Try to add one fact, for example, edge A. The graph now is the following. The only difference is that E and A are connected by an edge. If we ask the same query, so path AE, what we get? True, the first true solution, so A, B, C, E. Then what we get? We get another true, A, B, D, E. And then true, and then true, and so on. So what happens? We get an infinite number of solutions, since we pass an infinite number of times from the same nodes. For example, a path from A to E can be A, B, D, E. Another one, A, B, D, E, and then again A, B, D, E, and so on. So clearly we need a way to fix this behavior. A possible solution can involve, for example, storing in some way the already visited nodes in a list to avoid passing multiple times by the same edges. Other, more sophisticated solutions may use more advanced techniques, such as tabling. We will consider both of these solutions in the next video.